Hello, and welcome to our session on AppsFlyer SDK connectors for ad revenue and for in-app purchases and subscriptions. My name is Shlomi, an implementation engineer at AppsFlyer, and I will guide you through the deck. In this session, we will go over the SDK connectors for ad revenue and for in-app purchases and subscriptions, and we will cover the prerequisites, setup, and integration steps for each of them. While the generic connectors are part of the larger ROI 360 product suite, we will not cover other products or features that don't require the SDK connectors, such as API integration. The deck is built of short videos that demonstrate each of the SDK connectors and links to AppsFlyer's knowledge base and DevHub for you to use as reference later when you will work on your own implementation. So let's get started. Ad revenue is reported to AppsFlyer by either aggregated granularity via API or impression level of granularity via SDK. In this session, we will focus on the generic connector that provides impression level data via the SDK. The generic SDK connector works with ad networks to report ad revenue with impression level granularity and has better data freshness and earlier availability in AppsFlyer, comparing to the API integrations. The connector will generate a dedicated in-app event called AF ad revenue, and this event will be attributed to the original UA source. A few things to have ready before implementing the ad revenue connector. As this is a premium feature, first make sure your account has the appropriate package included. Next, and as we are going to cover the features available via the SDK specifically, make sure the networks you work with support this way of working. You can find a list of relevant networks in our knowledge base with the link attached to this slide. Lastly, make sure you have the AppsFlyer SDK implemented and running on the most recent version of it. The minimum requirement is to have the SDK 6.9 version implemented in your app. Now that we know what we need to have ready, let's see how to configure the apps in the dashboard and how to implement the connector in the code. We'll start with the dashboard. Navigate to the Revenue Settings page under the ROI 360 section. Select the app you wish to configure this for and choose the Ad Revenue tab. Click on New Ad Revenue Integration. Select your partner, in this case we'll use AppLovin Max as an example, and choose Impression Level via SDK as the integration type. Click Save and you are all set. There are a couple more places where you can see the configuration took effect. Under Configuration, select Active Integrations, choose the app you used in the previous step, and we can see the partner, AppLovin Max, listed here as an active integration. Click on it and make sure the Ad Revenue toggle is on and that the integration status matches what you've set before. You can also see this integration in the Cost and Ad Revenue status page. One more tip. If the partner you are looking for is not part of the list we saw, but it does support impression level data, you can use custom mediation, which is a generic solution for such cases. Make sure to choose custom mediation in the dashboard and to specify it in the code. More details can be found in our knowledge base. All right, dashboard configuration is ready. Let's move to the SDK implementation part. There are 3 simple steps you need to follow in order to integrate the Ad Revenue SDK connector into your app. First, you will import the Ad Revenue SDK. Second, you need to initialize the Ad Revenue SDK. And finally, call the log ad revenue method and include the relevant information in it. Let's first have a look on how this is done in Android. We'll start by making sure we have Maven Central included under repositories in the project's Gradle file. We'll then add the ad revenue library as a dependency in the apps Gradle file. And of course, don't forget to sync your project before moving to the next step. The initialization will happen in the app global class inside the onCreate method. Next, we'll need to collect all the details we want to include in the event that will be reported to AppsFlyer. To do that, we will usually use our mediation network's ILR, impression level revenue, SDK function that will give us the payload of the ad that generated the revenue. With the information in hand, we will build the arguments to send, like in this example, country, ad unit, placement, and more. The last step is to trigger the log ad revenue function. In terms of timing, you will most likely to call it after using the show function in your mediation network's SDK that pops the ad to the user. The log ad revenue function will include mandatory parameters such as monetization and mediation network, currency, and event revenue, and it will also include the optional custom parameters we've included in the previous step. Note that with AdMob's SDK specifically, you will get the impression revenue data in micro units, so you will need to divide it by 1 million before reporting to AppsFlyer in order for the revenue to show correctly. Once triggered, the SDK will send an in-app event to AppsFlyer servers, which will contain all of our arguments. To make sure it all works as expected, we'll review the logs generated by the SDK and find the ad revenue event that was sent. We can see the same values we've entered in the previous step, and we can see the 200 OK response indicating the event was sent successfully. We'll follow similar steps for iOS as well. Let's check it out. First, in your pod file, specify AppsFlyer ad revenue, and of course don't forget to run the pod update. Now, in app delegate, in the did finish launching with options method, call the ad revenue start function. This will initialize the SDK connector. Lastly, we'll trigger the log ad revenue API for every valid impression, in accordance with your mediation network's show SDK function, and include the relevant information generated by the ad that was probably retrieved from the mediation's SDK using the ILR function. And again, to make sure it all worked as expected, we'll review the logs generated by the SDK and find the ad revenue event that was sent. We can see the same values we've entered in the previous steps, and we can see the 200 OK response indicating the event was sent successfully. We can now validate the results in the dashboard as well. Note that if you are unable to find your test results in the dashboard, the 3 most common reasons for that would be 1. Impression events with revenue values above $10 and the equivalent in other currencies aren't processed by the SDK connector. So double check your integration and make sure that the values you are sending are below $10. 2. Raw data can take up to 2 days to reflect ad revenue events. If you require a more frequent raw data freshness, there is an impression level report in Data Locker. And 3, different dashboards like activity and cohort are updated every 4 to 6 hours or 24 hours depending on your package. So it might take some time until you find the results there. We'll start from the overview dashboard, where we can see the revenue that was reported by the SDK connector. Scrolling down, we'll find the dedicated in-app event for ad revenue called AF ad revenue. In the table, we can see the event distribution between organic and attributed installs with the revenue that each generated. In the raw data, when creating a new report, we need to make sure we are creating an ad revenue report. The AF ad revenue events will only show there, not in the regular in-app events reports. The report will include the relevant events with the revenue we generated and all other arguments reported by the SDK connector, like ad unit, mediation, and monetization networks. That's it. To get the full picture of your user's lifecycle and accurately measure ROAS, return on ad spend, AppsFlyer allows you to automatically validate and measure revenue from in-app purchases and auto-renewable subscriptions using the generic SDK connector. When using the connector, You shouldn't send in-app purchases events or use any of the legacy APIs, as this may result with duplication of revenue data. The connector will generate dedicated in-app events with names starting with AFPurchase and AFARS. But in case you will test it on Sandbox environment first, the event names will reflect it and will include the Sandbox label and an indication of the event source, SDK or S2S. We will show it later in this session. A few things to have ready before implementing the SDK connector. As this is a premium feature, first make sure your account has the appropriate package included. Second, and as we are discussing apps that has the option to subscribe or make in-app purchases, make sure you are all set on the store side and that billing is available already. Lastly, make sure you have the AppsFlyer SDK implemented and running on the most recent version of it. The minimum requirement is to have the SDK 6.8 version implemented in your app. Now that we know what we need to have ready, let's see how to configure the apps in the dashboard and how to implement the connector in the code. To set this up, there are steps to take on the store side, Google Play Store and iOS App Store. Make sure to follow the instructions in the links provided to avoid any issues with the integration between the stores and AppsFlyer. Once done, we can focus on the steps we need to follow on the AppsFlyer dashboard. Navigate to the Revenue Settings page under the ROI 360 section. Select the app you wish to configure this for, and choose the Purchases and Subscriptions tab. Use your account's private key. In Android, upload your private key JSON file you downloaded from the Google console, and for iOS, enter your App Store private key. Now, choose the preferred way you wish to receive the server notifications from the store. It can be sent directly to AppsFlyer, or you can add AppsFlyer as a subscriber to an existing service you have so that the notifications will be forwarded to AppsFlyer as well. Lastly, configure automatic services. You can set either or both validate purchases and auto-renewable subscriptions. Click Save and you are all set. Dashboard configuration is ready now. Let's move to the SDK implementation part. There are 3 simple steps you need to follow to integrate the SDK connector into your app. First, you'll add the connector to your project. Next, you need to initialize the connector and create an instance of it. And finally, call the relevant methods, including auto-logging of subscriptions and in-app purchases, and starting the SDK connector with observing transactions. Let's first have a look on how this is done in Android. We'll start by adding the relevant dependencies to the apps Gradle file, AppsFlyer Purchase Connector, and Google Play Billing. Google are constantly updating the billing libraries and versions, so make sure to always use AppsFlyer's latest versions of the connector so that it will be compatible with the billing libraries. Next, under Main Activity, we will initialize the Purchase Connector so that we can call the functions we need in our app. Log subscription. This will automatically validate and capture subscriptions happening through the store and will create an in-app event that will later show on the dashboard. Auto log in-apps that will do the same for in-app purchases. In this example, we are testing the flow before releasing to production, so we set the connector to work with the Sandbox environment. You must remember to remove this line or to set Sandbox to false before releasing your app to production. We recommend saving a reference to the build object. This will help avoid unexpected issues like memory leaks. And lastly, we will start the SDK connector by firing the Start Observing Transactions. To make sure it all worked as expected, we'll run a test app that is connected to the Play Store and review the logs it is generating after every user action. We'll start by making an in-app purchase of 100 coins. We can see that the purchase connector fired and that it was able to successfully validate the purchase with the store. We can also see the post API call to the VApp endpoint that came back with a 200 OK response. Let's try subscription flow. We'll pay for a premium plan. Again, we first see that connector fired. We can see the successful post call to the ARS endpoint. And we see that the subscription was validated with the store successfully. We'll follow similar steps for iOS as well. Let's have a look. We'll start by adding purchase connector to the pod file. And don't forget to run pod install to update your project. Next, we will initialize the purchase connector and set its environment to be sandbox if we're still testing the flow like in this case. We'll set the connector to automatically log in-app purchases and auto-renewable subscriptions and continue to implement the two methods we saw in the initialization step. Did receive purchase revenue validation info, which will allow you to get purchase validation event callbacks, and purchase revenue additional parameters that allows you to add custom parameters to purchase events. All we have left is to start the connector. We will do that by calling the start observing transactions method. This method should be called right after the AppsFlyer iOS SDK start method. Let's run a test app that is connected to the App Store and review the logs it is generating after every user action. We'll start by making an in-app purchase. We can see that an in-app test purchase has happened and that a post API call to the VApp endpoint fired successfully. For the subscription flow, after getting the OK for the purchase, we can see the successful post call to the ARS endpoint that validates the subscription. We can now validate the results in the dashboard as well, starting from the overview dashboard. We see our organic install, with 0 revenue reported for it, and we see that several in-app events were generated, some directly from the SDK, as the name suggests, and the rest came from the server marked as S2S. We'll go over to raw data to explain those 2 points. We now have all the in-app events listed in front of us, both the S2S events and the SDK events. Looking into one of the SDK events, we can see that the revenue is kept in a parameter called AF Sandbox Revenue. This is when we purchased the premium plan in the demo just now. When AppsFlyer recognized the purchase happened in a sandbox environment, the revenue is reported as sandbox to not affect the actual revenue shown on the dashboard. When we check an S2S event, we can see that it represents an event that happened outside of the app, outside of the SDK. Like in this example, expiration of the premium plan we subscribed to. Events such as this one, expiration, renewal, cancellation, and more, will show as S2S events. And that is all. The deck, including the videos and links, are available for you online at all times. So feel free to revisit it if you need to remind yourself with something, or if you wish to share it with your other team members this can be relevant for. We hope you enjoyed the session and found it useful. Thank you.